Now we have some certain definition: standard normal deviation, standard normal deviation, a normal probability distribution that has a mean of 0 and a standard deviation of 1. This is a repetition. Okay, you can see it from the because this is the main characteristics of the standard normal curve, with mean of 0, sigma equal to 1, and the total area, all of it equal to 1. It's a normal. So we have a scores. Those are the areas found in the table. You can see if we are dealing with, for example, this is z equal to 1.58. It is 0.9. The probability found below the area from the table. Okay, you can see 0.94. So if we are dealing with the area, those are the standard curve. This is the standard curve, standard normal curve, which is mean of 0 and standard deviation, and we can deal with it in different ways. Okay, if we are moving just only one standard deviation, it means that we are looking for this this shaded area, which is above the mean. X, it means the z will be like this one, the z-value and the standard deviation. To find the z-scores again, we do need to repeat it. The distance between a long horizontal scale of the standard normal distribution refers to the leftmost column and top row of the column. You do need to look to those things in order to be able to find the z scores. Area, it is the region under the curve, refer to the value in the body of the text. This is the area, which are the body in the body of the text. Okay, so the application from the normal distribution, returning back to the Alzheimer's disease. I think we discussed it in the classroom. The Alzheimer's disease. A researcher found that the brain weight of victims of the disease are normally distributed, with mean of, as you see, 1079.8 grams and the standard deviation of 105.76 grams. Find that a randomly selected victim of the disease will have a brain that weighs less than 800 grams. We have this example. So we have a population. We take a large population. This population, all of them are Alzheimer's disease, okay? And we weigh their brains. Their brains are of a certain mean weight, okay? And also we calculate the standard deviation for this for those Alzheimer's samples or individuals. What's the probability if we pick randomly a victim or Alzheimer's disease, okay, person? Okay, what's the probability, okay, that its brain weight will be less than 800 grams? This is how can we summarize the example or the question, because you do need to analyze it because before commencing in its analysis or its solution. So the solution, we must draw the distribution curve, okay, then transform to standard normal distribution, and the mean must be equal to 0 and standard deviation equal to 1. Now we do need to recall again, if we want to convert it to standard normal distribution curve, we do need to use the equation and also to draw it first. Using the equation should be of mean equal to 0 and standard deviation equal. The first step for solving such examples is just to draw the standard the curve. Okay, and in the curve you do need to mention the mean of those Alzheimer individual brain's weight weight actually, which is of 1076.8 grams, and you do need to indicate in a certain perpendicular also the average population, the predicted brain of the selected individual, which is 800, as you see here. It is below the overall mean for this population, and you can see that we also indicate the standard deviation for the selected population under study. This is the actual situation for this for those individuals. and we draw this bell shape curve. Till now it's not normal, so we do need to convert it to standard normal curve by using the equation. And remember that the standard normal curve is of zero mean and also standard deviation or sigma equal to 1. And if you want to summarize it like this one, you do need to know that it is of zero mean. This is the standard normal curve that we are converting it to the previous example to this value. It is of zero mean and also sigma equal to 1. And you see, as you see here, we add a value minus 2.62. From where we get this number? From where we get this number? As you see here, we transform the prime values to z value by using the previous equation, to see that the distance from the mean, which is the actual mean here, is 1076.8, to the x-axis is 18 minus this value, which is distance of 2.62 standard deviation. How can we use it? Now, how can we obtain this value, 2.62? 2.62 is the value that resulted from applying the equation. As you see below here, you can see the equation, just only the value minus the mean over the standard deviation, or the sigma in our example here. By applying this equation, just add 800, which is the value of the selected individual who is of brains weight of 800 just only, minus the overall mean of those Alzheimer individuals, over or divided by 105.67. This will yield 2.62, but it's in the minus, as we indicate in the curve, that this 800 is below the overall mean of the whole population, because it is 800, and also the overall mean is 1076.8, and it will yield minus 2.62. And if we go back to the z value table, you can see that it will be indicated as 0.0044. So the probability of obtaining a man or Alzheimer disease that holds a brain of 800 grams is 0.0044 if we select it in a random way. And that is a randomly selected patient will have a brain. This is the probability. So we solve it. So we do need to summarize our steps right here. Just only you do need to understand the question in a simple way. You do need to summarize it. What kind of information do we need? We need the overall mean for the population that we are working with. We do need to have the standard deviation, and if we don't have them, we do need to calculate them actually. And you have all the information to calculate the mean and also the standard deviation, which is the square root of the variance. And I told you the variance is summation of xi minus x bar square divided by n minus 1. Okay, and also the second step, you do need to find or to draw the normal curve, or the curve that summarize those individuals or the actual values. We do need to them in a certain curve. Then after that, we do need to convert them to standard normal curve, which is of zero mean and sigma equal to 1, by using what? By using the equation, which is x, or the value, minus x bar over the standard deviation, and this will yield the z value. This z value, we will go directly to the table to find the probability below. In the body of the text, we are 0.004 here that we found here. We can find it in the body of the table. Just go to see 2.62 in the z value, as we previously mentioned in the part of the table that we trained how to find the z-values using it. This is the value as you see here by applying this equation, 800 minus 1076.18 over the standard deviation that yielded minus 2.62.